and in our table of contents, we're looking at high availability and fault tolerance. We'll understand what that means. Serverless computing, serverless database, multi-cloud and hybrid cloud strategy, then platform as a service. These are things that we're going to be looking at this morning. So let's progress. So let's start with what is cloud computing. Remember, we're actually looking at advanced cloud infrastructure, right? So, but we must understand what cloud computing is first and foremost. Then before we now start talking about advanced, because if you do not understand what the basics is, how then are you advanced? What are you advancing into? Right? If you don't understand what the basics are, then you are certainly not advanced. You are going to advance into error. You're going to advance into misunderstanding. You're going to advance into complete knowledge because you don't even understand what you're doing. So we're going to start with cloud computing. What exactly is cloud computing? Some of us have heard the word cloud computing, especially those who are not on the tech side or the technical part of tech. They may have heard cloud computing. In fact, some may have seen adverts here and there. Oh, man, learn cloud computing, but has never bothered to wonder why or what cloud computing is all about, right? So then we're going to be looking at what cloud computing is. Now, cloud computing is the use of a network of remote servers hosted on the internet to store, manage, and process data rather than a local server, right? Now, this may sound a little bit technical for the layman. When we say using a network of remote servers hosted on the internet to store, manage, and process data rather than local server. Now, for somebody who's already in tech, this is pretty simple, can break it down as much as you want to do without any form of, but for somebody who's not into tech at all, you might be wondering, these things are sounding somehow. So, but then in the simplest term, cloud computing is basically, accessing computing services over the internet. Do you understand? That's, basic to the basic, just accessing computing services over the internet. Now you now begin to wonder what then are computing services. Now computing services are quite much, right? I will not be able to start reeling out all the computing services, but I will just talk on a few. Now, for instance, you have your cloud providers, right? Remember, I said that the cloud computing in the simplest form, accessing computing services over the internet. So if we're accessing the computing services over the internet, definitely there are some people who are providing us with these computing services. So the people who are providing us with these computing services are the people you call your cloud providers, right? Cloud computing, cloud provider, accessing computing services over the internet, right? Accessing computing services on the cloud, right? Now, so like I said, the people who are offering these services, these computing services that you and I are accessing over the internet, are the people you call your cloud providers. Now, example, your AWS, Amazon Web Services. And that's one of the example of your cloud provider, right? Microsoft Azure, an example of your cloud provider. Google Cloud, also an example, one of your cloud provider, right? Now, these are just the three major. There's also IBM. There's Ocean. But there's IBM. I've forgotten the other ones. But the three are the major ones that are much more familiar. Everybody's almost familiar with Microsoft Azure, Google Cloud, and then AWS. Now, these are your cloud providers. These are who are offering you those cloud services, right? They are offering you the computing services that you and I are accessing over the internet. Now, when we're talking about computing services, then what are examples of computing services? For instance, okay, let me not go through the infrastructure as a service, platform as a service route. Now, computing services, for instance, one of them is the database. Now, AWS, right, is offering you a service, a database service, right, on the cloud, which means that you can actually provision your database on the cloud and use it to make do what you want to make do with, right? Now, database services, example, one of the computing services that you can access on AWS. Not just AWS. When I use AWS, just know that it's same across all the platforms, right? All the cloud provider platforms. So database service, for instance, provision of your servers, your servers, which you can actually use to do quite a lot of things. Um, your servers, your database, your IoT, that's your Internet of Things, your in fact you offer so many things, your blockchain services, your load balancing services, your auto scaling services, like so many services that they offer, right? So you and I accessing these services over the internet is just your basic understanding of cloud computing. So anytime you come across cloud computing, and I'm talking majorly now to people who are not on the technical part of tech, who may have been in cloud computing, that should come to your mind first. Accessing the computing services over the internet, right? Keyword, computing services, keyword over the internet, which means that without the internet, you can't access them. Just like the same way you and I know that at least we know as basic we know Google Drive, right? And to the best of my knowledge, except maybe there's a new invention of sorts in town that I'm not aware of. It's to the best of my knowledge, you cannot access your Google Drive without an internet. If you want to access things on your Google Drive without an internet, I'm not sure you can do that. But like I said, except maybe things have changed, which I'm currently not aware of. So now that's how it works. Without the internet, you cannot access things on the cloud. Now let's move ahead. So then now that's us establishing what cloud computing is all about. Now don't forget, we're actually looking at what advanced cloud infrastructures. Now, part of the table of contents that we're having here is high availability and fault tolerance. High availability and fault tolerance. Now, what do we mean by high availability, fault tolerance? Designing for failure, redundancy, failure, disaster recovery, and all that. Now, when we talk about high availability and fault tolerance, we must understand that we all use applications, right? Almost all of us use different kind of applications on our phone. So I'm just going to be trying as much as I can to break it down to the level of people who don't have so much knowledge around these things. They can understand them and then grab them all. Now we all have applications everywhere, here and there, and we use these applications as much as we want to do. Now I'm sure that sometimes you have experienced. Let me give this example. If you have, I don't know, but I know that I don't know how it works now, but I know that the first time that WAEC introduced the concept of of having to go check your results online. The first time WAEC introduced that concept, I remember very well. First time WAEC introduced that concept, same thing with JAMB. I remember then the moment it was announced that the WAEC result was out. Just for the benefit of maybe people who are not Nigerians, WAEC is just your college. I think in America it's college, the equivalent of your college certification, right? So when you are done with your college, the final exam you write, you need to pass out of your college. In West African setting, it's called your WAEC. So now, at that time, I remember very, very, very well then. Now, once by the time it was announced that the result was out, now a lot of people were always rushing to check results. Sometimes then I remember very well, you'll be hearing things like, server has crashed, server has crashed, server has crashed. Way back then, I'm sure I didn't know what it meant then. Quite a lot of people also didn't know what it meant then. So with that, they're not able to access, the WAEC website to be able to check their results. Why? Because server had crashed. Now, if you're able to resonate with what I said just now, that would start giving you an idea of what we're talking about high availability and fault tolerance. Also, now, aside that time of WAEC and JAMB, I'm sure these days you might have come across something like that, or you may have heard something like that. So server crashed, the application went down for some reasons that you may not know, right? Now, what advanced cloud infrastructure has come to help you is that design strategies, right, to cope things like that, right, which creates a sense of high availability, right, meaning that my solution needs to be up almost every time, right? Then same with fault tolerance, which means that if anything happens, to my backend, for instance, if anything happens to my backend, my application should not go down. So my application should be able to withstand any kind of fault. So it doesn't mean that it will crash completely. So if there are issues, if my application are having issues, or the server are having issues upon which my application is being hosted, if it's having issues, my application is not expected to go down completely. Right? That's the idea behind when we talk about high availability and fault tolerance. You're not able to. My application is not supposed to go down completely, because of one or two little issues, right? So now, in order for us to be able to have that high availability and fault tolerance, we are not designing the application, we're designing it for failure. When we say designing for failure, we're not saying that we're designing the application for it to fail. No. What we mean is that we're designing it to withstand failure. Now, should there be any failure of any sort, it should be able to withstand it. One is redundancy. Redundancy talks about ensuring your system components have backup copies to do what? To prevent single points of failure. It's having backup copies to be able to prevent single failure. So when we say having backup copies, I'm sure that should be easily understood, right? You're having backup of something just in case if something fails, right? Hence, at least, let me talk basic again. You have organizations, and some individuals also do as well. You have your normal power that you use. Some have what's it called? Solar panel as well, right? Now, what if somebody is using your regular power, that's from your grid, national grid, and you're also using solar panel? Solar panel might be something like a backup, right? Should there be a problem with the power from the national grid, you can easily switch over to your solar. That's the basic explanation. What we mean by redundancy. Ensure system components have backup copies to prevent some point of failure. So rather than you hear that national grid collapse and I don't have power at all to be able to do something, I have a backup plan that I can switch to. Now, failover means automatic switching to a backup system if the primary system fails. Pretty simple as well. Automatic backup system, right? If the primary system fails. I'll keep using big things that you and I can relate so that you're able to understand it, right? So that I don't sound so technical, and at the end of the day, you don't seem to understand anything. Now, when we're talking about automatic switching to backup system if the primary system fails, basic again, or layman's understanding, you have seen where people they are using their power and they have a generating set that they're also using as well. That once power goes down, generates up immediately. The generating set does what? Picks up immediately. So wait for there's no sort of any sort of configuration to be done on the generating set for it to pick. The generating set has been configured for automatic switching. So should there be a problem, it switches automatically. It picks from there. So that's why there's no downtime of any kind. Right. So then disaster recovery, processes and tools to restore system functionality after significant failure or disaster. Disaster can always happen. Will always happen. Now, in your business continuity, when you look at, for instance, if you're setting up an organization, I'm sure you know, or maybe you don't know yet. If you're setting up, a very standard organization, one of the things that is expected of you to have is what you call your disaster recovery plan, right? Your disaster recovery plan, yeah, disaster recovery plan. So your disaster recovery plan is simply it comprises of many things, but one of the major things that it comprises of is that it talks about your plan, the plan you have to restore back your IT infrastructure to operation should there be a disaster. natural disaster, fire problems, should there be any of these disasters, the plan to restore your IT infrastructure. Please note that word, IT infrastructure. You need to restore your IT infrastructure back to operations. Should there be any problem? So that's the concept of disaster recovery. Your processes, your tools that you have set up to restore your system back, to functioning properly. This a failure or disaster. Now, key strategies. Don't forget looking at what high tolerance, designing for failure. Remember, I already explained, I gave an explanation of how when your server crashes, your application is down and all those things, So part of the reasons why, and I gave an example of how you're trying to check something. I mean, if, for instance, if the federal government today comes out to say, there is and maybe an employment or an opening whatsoever, for everybody to go and do what, go and apply, you realize that they are going to experience a crash. I think it happened quite long during time or somebody when we are applying for is it the immigration or something, they experienced their server crashed multiple times, right? So now you needed to avoid things like that, because why? If you are in a kind of business and you have an application that is running, you don't want your application to go down. Now, take for instance, WhatsApp goes down, what do you think will happen? Aside the fact that there will be so many kind of, people have some chaotic experiences here and there, because why? They need to communicate, through different, they need to communicate, some are definitely going to lose money as well, right? So that's the thing. So then part of us designing a system, to be able to withstand failure. And part of the strategies to doing that is load balancing. Load balancing does what? 27. Load balancing distributes traffic across multiple servers to ensure no single server is overwhelmed. Now, load balancing is one of the computing services that your cloud provider offers you as well. Remember, I said it when I was trying to talk about the cloud providers and the computing services that they offer. So load balancing is one of those services that they offer. And what is load balancing? It's just one of your tools or your system or your components, or one of your tools that is designed to be able to do what? To distribute traffic across multiple servers to ensure no single server is overwhelmed. Now that's exactly what you experience when there is when your server is overwhelmed, the server crashes. When your server is overwhelmed, it crashes. There's no two ways about that. Once your server is overwhelmed, it crashes. So traffic. When we say distribute traffic, I mean we're talking about traffic, from the outside, okay, let me not say from the outside, um, from your internet. For instance, if I'm accessing BBC now, bbc.com, once I do bbc.com, right, I'm trying to access BBC's website, right? So that's also me, moving in that traffic, right? I've also initiated a move in the traffic to be able to get BBC's website. So the same way I'm doing it, other people are doing it, other people are doing it, other people are doing it all around the world, right? So now the BBC.com, their servers is experiencing high level of traffic, right? So what load balancing does is that because you have multiple servers, so load balancing helps to distribute this traffic across different servers so that one single server is not overwhelmed. Now, when the traffic comes, your load balancer checks, okay, which of the server, which of the server to an extent does not have much load. Which of the server can I move this traffic to? Maybe server A, has experienced quite a lot of traffic. The server A is likely getting overwhelmed soon. So distribute this traffic across these several servers so that none of these servers gets completely overwhelmed and crashes. Now, auto scaling is also one of the computing services offered by your cloud provider. And what it does is that automatically adjusts computing resources based on traffic and load. Now, the concept of auto scaling is to do what? Adjust your computing resources. For instance, if your server now, for instance, has a certain threshold, that it works with. Now, if that particular server, the CPU, the storage, everything gets completely filled up, we are going to still experience the problem of server having issues, right? So, but what auto scaling does is that it adjusts your computing resources, which, for instance, now your server, it adjusts it in the sense that if maybe your storage is getting full, right? Auto scaling, can help adjust that resources upward, for you to have, a lot more storage, be able to stand your traffic and your load that is coming to that server, right? So when you don't have much traffic, now take for, I'm sure you know that. Let me use an example. Your e-commerce sites, your e-commerce sites, most of your e-commerce sites that you visit, you know that there are certain times, right, in the season or in the year where your e-commerce site experience so much traffic. And for instance, one of those times could be during your festive season. Now, when you're doing your festive season, right, maybe let's say like December, people are shopping, people want to buy things, they are happy. I mean, they want to get themselves happy. Some just want to feel like, give themselves some treats after everything they've done in the whole year. Some people are just happy. They want to just make themselves happy. And okay, let me go online and shop for this. Let me go online and shop for this. Now, at that period of that season, you have so much traffic on that e-commerce platform. I'm sure you know that already. So you have so much traffic. And when you have so much traffic and so much load, that can also affect servers, I'm sure you know. Now, aside load balancing that helps you to distribute this traffic across these servers, and now auto scaling also helps you to adjust your computing resources either upward or downward. Because during the period, for instance, currently right now, today is Tuesday morning, I'm not sure the e-commerce site will be experiencing so much traffic now because people have gone to work, people have gone to look for money and all of that, right? But weekends, people want to, stock up their houses, people want to do quite a lot of things, so the traffic level at the weekends are usually higher than during the weeks, right? So that's the thing with auto scaling. Let me move quite fast. Time is running fast on me. So multi AZ, which is multi availability zone and multi region. Deploying application multi availability zone or across regions for increased availability and resilience. Let me see how fast I can talk about it. Now, when we see, remember, these are key strategies that helps you to design your infrastructure or design your system to be able to withstand any form of failure. Now, multi availability zone and multi region, talk about. Now, your cloud providers, they have their data centers across different zones and different regions, right? For instance, I'm aware in Africa, they have their data center in South Africa. AWS have their data center in South Africa. In Europe, they have across different places in Europe. They have in Asia, they have in America as well, South America, North America. Now, for instance, the data center that they have in Africa, do you know what that helps? Now, when I provision a server or when I provision some sort of infrastructure, right, in the South Africa region, that's the African region, which is South Africa, what happens is that now for people within the African region that will be accessing my applications, right, they will experience faster delivery in terms of being able to access application. Why? Because of the region where the data center is and the region where I am hosting, right, or I provisioned my server. So accessing my solution will be a lot more faster for people within the African continent, right, as against people as far as maybe Asia. Do you understand? So that's just the concept behind that. So rather than me provisioning my server, for instance, in Asia, where somebody in a remote part of Africa, maybe DRC or East Africa, Kenya, and the rest, they will not like they will be able to access their solution. They will, but in terms of speed, they will have issues in terms of speed. So those are some of the things that you do. So that's why we have the multi that. Let's quickly move to serverless computing. Man, 35. But let me move very fast. Serverless computing benefits, cost efficiency, pay only for what you use, scalable, automatically scales with demand, No server management required. Focus on code, not infrastructure. Serverless computing. Okay, the idea behind serverless computing is just simple. It's also one of the computing services being offered by a cloud provider. And the idea is that, okay, you want to do some certain things. You don't necessarily have to come and provision your server, right? You don't need to provision your server for it to do this. That's why it's called serverless computing, right? You don't need to provision. For instance, I want to do a small deployment of something, and I have to start provisioning server, setting up this, setting up that, setting up this, setting up that before deploying. No, serverless computing concept. You don't necessarily have to start provisioning server to be able to do that deployment. The benefits of efficiency, you really pay for what you use, you scale with demand. When demand is high, you can scale up. When demand is low, you can scale down, right? So, and no server management required. So your basic thing is just focus on your code, pretty much focus on your code and not the infrastructure, right? So, and then the key providers, like I said, these are the key most popular cloud providers, AWS. And AWS, if you want to access the serverless computing service, it's called AWS Lambda. So, and the serverless computing service that automatically runs code in response to events. Then under in Microsoft Azure, it's Azure Function. So event-driven compute service that allow you to run code without provisioning servers. Then Google Cloud Function, event-based serverless functions for building lightweight, scalable applications. The serverless databases as serverless an event-driven architecture. For serverless databases scale automatically and are cost efficient. AWS, Aura, serverless, Azure, architectures, application response to events such as database updates, API messaging groups, this part. Event does your application response to event like the database updates, API messaging queues, application response to those events, multi-cloud. Okay, let's talk on this one. Now, multi-cloud and hybrid cloud strategy. Multi-cloud and hybrid cloud strategy. Now, multi-cloud is using two or more cloud providers, for instance, your AWS, Azure, GCP, to avoid vendor lock-in and optimize for specific workload. The hybrid cloud is using your on-premise infrastructure with private and public services, allowing for flexible cloud distribution and business continuity. Okay, multi-cloud. Since you already know our cloud provider, now you are using a multi-cloud, right? So to avoid your vendor lock-in as well, right? And that can help you to optimize, your workload very, very much. So you're not relying completely on AWS, for instance. You're not relying completely on Azure, right, or GCP. Now, when we say hybrid cloud is a combination of on-premise infrastructure with private and public cloud services. Right now, your on-premise infrastructure is different from your cloud, right? Cloud computing services. Your on-premise infrastructure, when you hear your on-premise infrastructure, what it means is very simple. It's just having your IT infrastructure sited within your facility, right? Which means that you don't need to necessarily rely on your cloud providers anymore. You may not need to use your cloud providers, right? So that's the concept behind your on-premise infrastructure. So having your IT infrastructure sited within your facility, right? So that's the concept of on-premise infrastructure. And when we talk about hybrid cloud, it's a combination of using your on-premise infrastructure and your public cloud services. Take for instance, maybe I might not have to stop here because of time. So when we say hybrid cloud, organizations these days they use cloud services because it's a lot more cheaper for them and a lot more manageable for them, and as against having to setting up your IT infrastructure within your facility, it will cost, it's capital intensive. So you don't necessarily have to start looking for that level, or you have that such capital. You're not investing it into setting up your on-premise IT infrastructure. You don't necessarily need to do that. You just rather, use cloud. Just work with any of the cloud providers and use their services to do the same thing. So because if you are setting up your on-premise infrastructure, it costs you a lot of money. maintenance is there, so many things are involved, right? But the organizations that use a combination of on-premise infrastructure and cloud services as well. Take for instance, um, um, the way the country is designed. Let me use Nigeria for instance now. Nigeria as a country, or US as a country now. Let me use Nigeria. Nigeria cannot afford to use cloud providers, Like, I mean, I'm about Nigeria as a country, yes, Nigeria, like the federal government right now, cannot afford cloud providers just for all of the things they are going to do. No, we have an on-premise infrastructure. Why? Because now there are some certain things about the country. There's some certain information. There's some certain information about the country that you want to, the cloud provider. Fine. It's not like your secrets are being leaked to the cloud providers in the sense that even when you're using the cloud providers, for instance, if you are using, there are some services like for instance, you can use an encryption. You can encrypt quite a lot of things on your AWS, for instance. You can encrypt your keys. You can that nobody can decrypt it, right? So which means that nobody can have access to it as well. We all know cloud providers are by private organizations and resident in the country, right? So if a country cannot afford to just hand over all of their secrets, all of their, I mean, when I mean secrets, I'm not saying they are bad secrets, but your information about the country, you cannot hand everything over to a provider. So that's the reason why they can have a combination of on-premise infrastructure. Now there are some informations that fine, you can use your public cloud, with that, set up your database and all of that, your public cloud. While there's some informations that you need their on-premise infrastructure, which they have 100% control over, to be able to use it, because some of those information cannot afford to leak out some of those information. So that's the thing with combination of on-premise infrastructure and private cloud services. I've just checked my time. I guess I might have to just, when else I come back, because at the start, you can still see more slides. And now for me to explain this slide, I will not explain all these slides in 3 minutes. I explain all these slides in 3 minutes. So, yeah, basically that will be it. So I'm going to pause here for questions, so that if you have questions, you can attend to the questions before 9:45. So there's questions. You have questions? Okay. It appears nobody has question. Thank you very much for time, and then do have a great day.
All right, thank you everyone for joining. We'll continue with the question and answer sections tomorrow.